Welcome to Data Science Using Python. In this video, we're going to look at one-way ANOVA. We'll get to multiple comparisons later in a previous or subsequent videos, so don't worry about it. All right, so what we're going to do is we are going to add a few packages. But the first thing you should do is make sure you're in the right working directory where your files are going to be, because you're going to need to download a different one. Okay, so we're going to add in here stats models formula API. And we're going to use stats models or stat model stats ANOVA. This one's going to allow us to use a formula in our coding, and this one is going to allow us to do ANOVA, which it looks pretty obvious that it would do that. We're going to be using the Fructose.csv data file, which is in the repository that's linked in the description. So you probably don't have this one because we haven't used it yet. But if you do happen to have it, you can just put it on your desktop or wherever this working directory is. All right, so I'm going to run this real quick, make sure everything reads in, and bingo, everything looks good. No errors or anything like that, so we're going to run with this. You'll find that this doesn't take too much effort here, but what I do want to do is always look at the data first. Make sure you have some idea what you're looking at and what you're working with. Okay, so we're going to do a box plot, which we've already done before. So if you haven't looked back at that video, go back and look back at that video so you can follow along and be able to modify this plot, because we're just going to do the rough plot. Okay, so it's a box plot, and in this data set that we've called FR1, there is a variable called fructose. And I think this is the amount of fructose in varieties of oranges per like 100 grams or whatever. And there are 4 varieties in here. If you want to go look at the data set, feel free. I'm not going to do that right now. What I'm going to do is get our picture going here. So this is the general way to subset the data. If you don't know how to subset the data, there's another video that will show you how to do that. Notice I'm very much self-promoting here, and I don't mind it. So there are 4 varieties, and I'll just copy and paste them in at the moment, and then we'll move them over or get them to work out here. So there's a comma there, and then we'll put a comma here, and we'll get our picture, but we have to change the varieties, otherwise this isn't going to work. So we close off our parenthesis. So we have varieties A, B, C, and D. Don't ask me how they collected it. Don't know. Here we go. Let's run this and see what we get. And it gave us a picture. Give us an error. So it says something about ambiguous truth symbol here. So let's see, what did I do wrong? So this needs to be in parentheses. Sometimes you just have to look at what you've done and go, what did I miss? And bingo, we get our picture. Notice I left that mistake in because I want you to know that these are simple mistakes that people make. And when you see it, you go, oh, wait, even somebody who knows what they're doing, or supposedly I know what I'm doing, makes mistakes like this. So don't freak out when you make mistakes in computer programming. That's 90% of what you do. All right, so we have this picture here. I'm going to kind of blow it up a little bit. And you can see there's variety A, B, C, and D. They're in the order over here. We could modify this. And it looks like variety 4 seems to have more fructose than the other 2, or the other 3. Don't really see a whole lot here. And you might say, oh, well, you have an outlier here and an outlier here. I'm looking for the big overall picture. I'm not going to sit here and nitpick over that. I'm looking for big changes like this one here. Okay, so it looks like we have this. So this looks like we should maybe do an ANOVA to see if there really are differences in here. Okay, and this is going to be pretty easy, but we have to go back and look at what our hypothesis is. Have to set it up because it's a hypothesis test. ANOVA is a hypothesis test. So here we're going to have, first we should have mu A is the mean of population of, or the mean fructose of population of variety A. And then I'm just going to copy and paste this because it's exactly the same all the way down here. There's this should be pretty easy for you to do. B, C, D, and copy and paste is your friend, by the way. and D. Now that I have this, now I can set up my hypothesis. H naught is that each of these are all equal to each other, so there is no difference. And you have to remember the alternative here. It says there's no difference between any of them. Most people think the opposite of that is they're all different. No, it just means that any two means differ. Okay? You can't have one mean differ. Differ from what? Right? To do subtraction, you need two things. All right, significance level. Well, let's see. This is oranges. I actually don't like oranges. So it's not that important to me, but 0, 2, 3. Why? Because we don't want to use 0.05. 0.05 is boring. All right, so let's use what is our test statistic going to be? We are going to use, like we have right here, this to give us what we need. And so this is what we're going to put down, in the function we're going to use is ANOVA LM. And you'll see that here in a minute. And now we just need a decision rule. And I'm going to scroll this up. Okay. So our decision rule is always the same. If the p-value is less than alpha, reject H naught. Okay, so now we can execute. And this is pretty easy to do. It's just 2 lines of code this time, actually 3. So we're going to have a formula, and I'm going to call it Formula 1. And I'm going to use a formula very similar to what you would use if you were using R. If you don't know what the formula in R is, it doesn't matter. So it's basically your outcome variable. And then you have this little tilde sign that is on the US keyboard. It's at the shift top left key. Okay, so, and then here I'm going to put in C because it's a category of variety. And that's all I'm going to do here. This is the formula. It's going to say fructose against the category of varieties. And then I'm going to do FR1, which is my data set, LM.LM here. And I'm going to not put a dot in there. I'm going to put underscore. It gets a little weird when you put dots on things on some of these. So SMF, which is what I read in before, OLS. Okay, so this allows us to use a formula. So here I am just going to put in Formula 1, and then I have to put in the data is FR1, and this should get us going. Oh, I forgot the equal sign. Equal sign, and the next thing I have to do is, oh wait, I gotta fit this. Chain that on there, and then I can run this bit, and it's really not going to do anything. It's very underwhelming, but it does like nothing, absolutely nothing. So now you need to get this out of here. So what I'm going to do is now actually use the ANOVA. Okay, SMA ANOVA LM. Then I'm going to put in my model FR1 underscore LM. Okay. And when I do this, I can run this, and bingo. A little ANOVA table comes out here. And let me see if I can't enlarge that. Yeah, it's enlarging. Just be patient. Okay, so here we go. So we've enlarged this a little bit, and you can see that this is our p-value right here. We have the f-value, p-value. You can see the mean square errors here. They call it the mean squared residual. It's all the same. It's all good. All right, so we can make a decision. Since the p-value is equal to, and when I highlighted that, I copied it. So this is less than our 0.023, which is equal to alpha. We reject H naught. All right, and so we have a conclusion. We have sufficient evidence to claim that the amount of fructose in oranges differ by variety. And that probably makes sense anyway. All right, so we did this. We've got our ANOVA down. We have, if you want to, you could copy and paste the whole table here. Some people like to see the whole table. But make sure that you show all the evidence you can when you do stuff. All right, so we're under our 11-minute mark, and we will see you in the next video and learn how to do a two keys post hoc test. See you there.